Good evening, good evening. So it is a RockTrue Science experiment day, my favorite day. So, every third week out the month, you know, we do our experiments. So after I go over these that we have from Male Science, it is a chemistry. I think these are mostly chemistry experiments. So chemistry experiments subscription box that you can order through their website, and they send you all of the stuff that you need for everything. Even these goggles came from them. The gloves were in with each experiment, and then probably like the only thing you have to provide is like the water. So I broke my beaker last time, so I'm just using a jar, so a glass jar for this instead of a glass beaker. So you can see the substitutions are quick and easy, but I'll end up ordering a new beaker this week. I just forgot to. So we have two experiments that we'll be doing from them, and then I'll be talking about an experiment that you can do at home. It's quick and easy. I wasn't able to get the materials for it in time for this, so that's why I won't be doing it, demonstrating it. But I can talk y'all through it, and then if you try it at home, tag yourself to the Facebook page or comment under the video if you are watching us on YouTube, and tell us what you thought about it, and I don't know what you learned. So this is fun for me. So we're going to go ahead and get started. So our first, not fire phone. So our first experiment we're going to be doing igniting iron. So as you can see, it's not hard, but it is dangerous because fire is involved. So if you're doing this experiment with your children, make sure that all safety precautions are taken. I'm outside on my balcony, not in my room lighting stuff on fire. So I have everything set up here. Let's see if I can see that. Get y'all in here. There we go. So this, turn that, yeah, turn it like that so you can see it. So I'm gonna move, get my papers out the way. Not trying to catch any residual fire going on. Okay. All right. And so they put these sticks in the material box so that you have more distance from your hand to the flame when you're lighting stuff. So that's fire safety. So this experiment, you have this is the platform that holds it, so it keeps the flame off of the bottom surface. And there's a little piece of foil that you that comes with the kit as well to sit in here to set your piece of iron wool. So this is steel wool, and it's measured at 1.5 grams. They sent three of these, so I can actually do this experiment several times. And they do that with all of the experiments. They send you more than enough materials to do it a couple of times. If you don't, if at first you don't succeed, try again, and they make sure that you can. All right. So we're gonna fluff this out so that this is nice and big with some distance. Okay. And this is all iron. So I don't know if here I'll burn it first, and then as it's burning, then I'll explain to you what's going on with this experiment here. So last week we talked about how iron uh, was super important in our bodies because it is the main component of our blood, and it is the main thing that binds oxygen. So that is a key component to why this experiment works. Okay. All right. So I think that's fluffed out enough. We'll see. If it doesn't work, we got two more of these, so we can always try it again, right? And then there's that. So make sure it's all contained inside of here. Okay, so you all can see that. And I got my personalized lighter, Sagittarius. They're so cool. I love mythology. It's like you get to think of random stuff and then put a story to it, and it's just fun. All right, so we got that lit, and then we're going to just set it on fire. So I don't know if you can see this, but it's burning pretty quickly. And as you can see, there are no flames. And it almost smells like a little like burning hair and burning paper a little bit. And it almost looks like little fireworks and sparks and stuff like that. It's so cool to watch. Oh, my camera's not dirty. But the reason why this works, so yeah, all my irons all burnt up. So the reason why that works. So the way is that not focusing? Here, let me make sure my camera's clean. My daughter's been using it, so she's been probably putting her hands all in the camera and everything. So iron, it binds oxygen to it. So when you burn, let's say, a piece of paper, so you notice when you, especially like tissue paper or something like that, it like bursts into flames really quick, and the flames are like real big. So the reason why that happens is because when paper burns, it releases carbon atoms. So the little ash and stuff like that that you see when when you see fires and things, that's really carbon pieces that's escaping the material that's being burned. And so once those carbon pieces leave the material, they bind oxygen in the air. Oxygen is flammable. So it's basically taking the material that's being burned and then moving it to more air to burn some more. And that's why there are flames. Now, with the iron, it did burn, but there were no flames because because iron is much heavier than carbon things that burn. So it doesn't release iron particles into the air. So it brings oxygen particles to the iron that causes the iron to burn. Now, I know you're like, oh, why can't you just burn a car or burn like cars and things don't burn as easily because the iron and steel used tend to be thicker. So as the heat is being applied to the iron, unless it's like a lot of fire, so like unless you like blow a car up and it's engulfed in flames, then it's going to be very hard to burn a car. Like you can't just walk up to a car with a lighter or a match and set the car on fire, because the heat that is applied to the metal, it dissipates across the surface or into the metal, so it doesn't actually allow the iron to burn. So with the steel wool, the iron fibers are thin enough so that as that piece of iron starts to burn and the oxygen binds to it, it just burns along the iron threading instead of not burning. So that was cool to watch. I'm almost definitely gonna do that again. So like I said, we got a couple more in here, so I'll go ahead and do that again. I'll see if I can get y'all at a different angle so you can kind of see it differently. And like I said, I wasn't sure if my camera was clean enough or not, because my daughter, she be in stuff. She not even 2 yet, but she too smart for me. She be playing her little ABC mouse games where they you can build sentences and stuff. And she get the stuff right. She can build this, but she don't talk. She don't talk to me. She doesn't talk to me, but she can build sentences and stuff on this little game. So I'm just like, this girl, I don't know what I'm gonna do with her. All right, so we got it fluffed out. So let me see, because maybe if I fluff it a little bit more, it'll burn slower, and then we can kind of see more action. Lights, camera, action. So this is pretty cool. And I mean, I guess like the reason why like your dish, what you use to like wash your dishes, like the steel wool that you use probably wouldn't work well for this, is because that's an alloy. So a metal alloy is when you mix two metals together. And so basically you end up with combined properties of the metal. So if you have one metal that has a lower melting point than another one, when you mix them together, they can end up with a higher melting point, and that's kind of the situation with a lot of the things that are made for safe home use. So let's get this. So I'm actually gonna sit y'all in my lap. Okay, I think that's a better angle. So let me move my paper. And then I'm gonna actually sit this here so you can see, because you can see the color is even different. So we got us a whole different situation going. Lit. Oh, the flame went out. Did it? There we go. And go. Oh, that one went fast. It almost smells like barbecue. It's crazy because like looking at this makes me think of the brain and what like firing neurons and stuff. Like when you have a thought, like that's kind of also what your brain looks like if you get it. Like when they show the brain imaging during different stimuli and stuff like that, the signaling looks a lot like that pattern. So that was pretty cool. All right, now so this next experiment I'm actually really excited about. There's a lot more steps to it than this one, which is why I decided to start with the simpler one first. But now we're going to the fire foam. Okay, and so it's literally foam. All right, so we have our get the instructions. Okay, so I have everything laid out here, and then I'm actually gonna have to like stuff falling in the cup. All right, a little bit of dirt. Dirt ain't hurt nobody. It has, but it won't hurt this experiment. So we have our beaker. So everything that I have here was provided in the main kit and the experiment kit. So I didn't purchase any of these items separately except for the jam jar. All right, so let me bring this stuff back over here and then I'll get y'all focused in. All right. So we have and then our jar, this is where we'll be doing our foam and igniting everything. So we have the soap here, and we take the soap, and I'm actually going to mix it in this cup. So we take the soap, and it's literal soap. So I'm pretty sure this is just like standard, like regular soap. So like dish soap, essentially something that makes bubbles. All right. We'll put that in the trash pile over there. That's going in the garbage. And this is disposable. You can throw this right in the garbage. It's not a pollutant or anything like that. So, and then I have my water here, and we're going to measure into this cup 100 mils, 100 milliliters, and then we're going to pour it in and mix. I don't know if that's going to fit in this little cup. Okay, that was like perfect. Boom. Exactly 100 mils fits in that cup. Okay, now I know that. So now that that's mixed, now I have to set up my, what they call this, our gas generator. So these are little little iron rods. And I put that in, and it came with the cork with the hole. And these are iron. So put that into the hole. Make sure it's stable. Okay. And then cork. So we got our tubing. This also came in this experiment pack. Over that, and make sure it's secure. So push it down as far as it'll go. Okay. So nice and secure. Put that on our beaker. Oh, not yet. So this has to go into the beaker. So we get our funnel, and then we pour our soap water in. Now we put the stopper in. Okay? No, still not yet. Getting ahead of myself. So now we have to make our mixture. So the soapy water is basically creating a substrate for this stuff to go into the beaker, and that's what's going to make the bubbles that we're going to set on fire. So then we get our. So they gave us some magnesium strips. They gave us some magnesium strips, and they almost look like regular foil, little foil strips. And I feel like not this exact experiment, but I did do something kind of like this with sulfuric acid and magnesium. And magnesium is a great metal to create hydrogen gas. So that's what we're doing here. We're making some hydrogen gas, and we're going to trap the gas in the bubbles. So instead of the gas being carbon dioxide or like regular air in the bubble, like normally when you blow bubbles at the park or something like that, we're putting hydrogen gas in these bubbles. All right. So pour our any oxygen in the flask. I have the sodium. Was that one? Or does that go in? This goes in there, right? I knew something was backwards. I'm like, nah, I think regular water goes in here. And we just gonna rinse that. Okay, here we go. So now we put our. Now I gotta get some more water because I need regular water for that. Okay, there we go. So now we got the solutions in the correct jars now. So we got our soap in here, and then we're gonna put 100 mils of water into our flask. So we just need regular water, not soapy water. Okay, there we go. See, this is why they give you a couple to do, just in case you get something mixed up. It's like, oh, I don't think that was right. All right, there we go. And then we take our. So this breaks down into sulfuric acid. You see the HSO4. When you pour this in water, the sodium dissociates from it and hydrogen replaces it. And then you get H2SO4, which is sulfuric acid, which is a extremely corrosive acid. So be very careful with this solution. So we put the whole bottle in. And so as you can see, it's solid. So it's basically a salt. So we call these salts. Anytime you mix the alkali, so we talked about this group. So sodium is in the alkali earth metal group, and NaCl, Na anything is basically considered a salt. Mg anything is a salt. So this is an acid salt. And so the water, like I said, the water dissociates the sodium from the salt and replaces it with hydrogen. And then now you end up with a liquid solution of sulfuric acid. And so we're going to stir this slowly and carefully so as not to splash it. And get it to dissolve. And it's got little bubbles in there. That's our sodium moving around. And this is also why you must wear gloves when you handle these type of things, because you don't know if something's going to splash or what. What's going on?
The mama just took over the whole balcony, didn't you? Doing experiments.
She ain't even been asleep that long. She probably woke up because she hungry. All right. And it's crazy, like you can see all these little bubbles forming. So like I said, that's the hydrogen being basically broken out of the water molecules and binding with the HSO4 molecule and creating sulfuric acid. So now I have a nice mixed in beaker of sulfuric acid. Then we're going to get our measuring spoon here. And they even give you labels so you can label your beaker. That's also another safety precaution. But since I'm the only one doing this experiment and I don't have to worry about anyone coming along and not knowing what I'm working with or anything like that, it's not necessary. But absolutely label your things, especially if you're using similar containers, because you might not remember what one is holding, what the other one is holding. You don't want to do that. So
I need to get her church. She just wants to be out here.
well, I'm doing a dangerous experiment, so I don't really want her like just able to walk up and grab stuff.
Oh, she's out here with me. She didn't want to be inside.
So we need 2 big spoons of this, and we're going to mix it in. And this is Na2CO3. So once we drop this into the solution, the sodium is going to dissociate, and the CO3 or carbonate is going to bind with the sulfuric acid. It's going to bind with the sulfuric acid, and it's going to create That's why Mama knows best, because I just told her I didn't want her trying to grab stuff. That's why she got mad, because she wanted to grab something and we wouldn't let her grab the stuff, so she got upset. But anyway, so this ends up binding with the sulfuric acid. It's a very quick reaction, so you're going to see a lot of bubbles, and the CO2 is going to force the oxygen out of the beaker. And then as that's happening, I'm going to put the cork on there, and then the CO2 gases are going to go into this jar and make a bunch of bubbles. And those are going to be full of hydrogen. So let me get my spoons of this going here. I don't know how they be wanting me to open this stuff because it's got a cork in it. That's useful. So, 2 big spoons. It's like dripping out. Okay, here we go. So one, you see the fizz? That's those CO2 bubbles. Oop. Got a little extra. I don't know how this is gonna work out, but we sure will find out. Then we put our magnesium strips in there, and that's gonna start the reaction as the magnesium breaks down in the acid. So we need 3 strips. And that's 2 more. So you see those bubbles? That's our hydrogen forming from the acid breaking the magnesium down. And then we put this in there. Let me see if y'all can see what I'm going on over here. And so now we just wait for the magnesium to go ahead and keep breaking down. And those bubbles, let me see. Yeah, you can see the bubbles. So the bubbles that's forming that air, that's pure hydrogen. So the sulfuric acid and yeah, the sulfuric acid is breaking down the magnesium. So we put just enough of this, the Na2CO3 in there to blow out, to create, gas, to blow out any oxygen that would have been in there. And now the magnesium is reacting with the acid and creating pure hydrogen. And so these bubbles that are forming in the soap solution are filled with hydrogen and not carbon dioxide, like when you blow bubbles with your as a fun game to to do in the park and popping bubbles and things. So these are filled with oxygen, and then we're gonna just here, I can leave that there. Yeah. So I'm gonna leave that there, and then we're gonna let the magnesium finish breaking down. And then once it's done, we're gonna set it on fire. My favorite part. I'm gonna start cleaning some of the stuff up. I'm not sure why she just why she's so upset like that. She had to take a break to sip some water so she could replenish her screen. there, there it goes. That's my little bit. All right, so it's starting to slow down. I'm gonna stir it up a little bit. Put this stuff back in. So this, and then this little thing that they sent in the pack, this is actually to absorb any liquid that's left in here, like to help absorb it, because like I said, that is an acid, but you can pour it down the sink, but you have to neutralize it first. And this is my little empty bottle. I'll actually put this one in. Okay, it looks like it's starting to slow down. So I'm going to take this tube out of there so we can see our light show go. So we can see our light show going. Right. So I got our match light up stick. So I'm going to take, and it actually says take off my gloves, so that's why I'm taking off my gloves. Oh, they actually lighten it while the tube is in there. Okay, we're going to see this then. We're going to see how this goes. Because, I mean, it's their tubing, so if the tube melt or catch fire, it's not like I'm missing anything. And then we're going to put that in there. So you heard that loud pop. So because of the jar, so that was fun. So because the jar is so deep, the hydrogen gas, when it lit and all the bubbles popped, like everything just kind of lit at the same time. So it created like a small vacuum. So when the fire lit, the hydrogen like basically shot all the air out of the glass really fast, and that's what that pop noise was. That was fun. That was a lot. That was a lot of fun. So this one actually didn't like burn because I don't know. I guess they're supposed to burn, but my jar was too deep. I probably should have added more water so that the bubbles would have been closer to the top. So we can actually do this again because I have more magnesium and I think there's enough acid still active in there to get more bubbles out of it. So I'm just gonna add more water to this beaker so we can get this up closer to the top and see if we can get some flames. Okay, I want to see some flames. So I'm putting my gloves back on. Safety first. All right. And it's crazy because I went to go see the escape room yesterday, and they had like a lot of science in there. I'm just like, oh, this is like creepy and nerdy at the same time. Hey, hey, Marley King. So I'm gonna pour some of this water in here to get this closer to the top. Let's see. Hopefully, it doesn't make it too dilute so that we can't get bubbles. Okay. So we're gonna retry this. So get my magnesium strips, and I would put the magnesium all the way at the bottom. So I gotta dump everything out. Okay, here we go. And then we're gonna see. There should, like I said, there should still be enough acid in this flask to get another reaction going. And the beaker here is actually warm because the reaction with sulfuric acid and magnesium is it's an exothermic reaction. Okay, so exothermic means it gives off heat. So hopefully, do and I think it's 3 more strips in here. Yep, it's like 2 more strips. So we got a couple of strips. So we'll see. We'll see. We're gonna see if it'll run. If we can run that back. All right. So I'm gonna try and do this quick because we don't want a lot of air in this glass. All right. There we go. So it's trying to push the cork out. So I'm gonna have to hold the cork down while this is going because now I broke the seal and the gases in here are pushing on the cork so hard that it's pushing it out. So I can't get it to stay now. So it's making more bubbles. That's what we want. And so basically what the magnesium is doing, so get back in here. So magnesium is replacing the hydrogen on the sulfuric acid. So magnesium, as we remember from our our trip through the periodic table, it has a 2+ oxidation state. And so it can replace both hydrogens on the sulfuric acid. So H2 gas is being released in this reaction, and then you end up left with magnesium sulfate, which is what we started with, right? We mixed that in the water. But no, we had sodium sulfate. So we mixed the sodium sulfate into the water as a salt. And then the magnesium comes back and replaces the sodium as a salt. And you create a magnesium sulfuric salt. Magnesium sulfate salt. And so that's why the water is getting a little bit cloudy, because that's actually that going on. That's the magnesium sulfate being left behind as the hydrogen gas is being sent through the tube into this and making the bubbles. And so now, okay, the cork is acting like it's trying to stay. So now we're going to light these bubbles on. All right, so let me get y'all back down here so you can see. And maybe we won't get that loud pop sound. Because that's actually another experiment too, the pop from the magnesium breakdown, giving off hydrogen gas. Oh, hold on. See, I'm gonna get it back. I gotta take my gloves off again. Because, yeah. So the reason why you take your gloves off is because it's a fire hazard. So if the fire happens to jump on you or burn your hand, you don't want gloves on your hand, because it's going to melt the glove and make an even worse burn than just being burned by fire. So yeah, take your gloves off before handling fire. And it still just did the pop because they're all like burning at the same time. And as you can see, the magnesium is still reacting with the sulfuric acid. So it's going to continue to do that until either there's no more magnesium, until all those completely dissolve, or until there's no more sulfuric acid in there for it to react with. And it has to be the acid form, the H2SO4 form. All right, so we got some more bubbles. I'm trying to see if it'll light. It sets everything on fire so fast that you just get that hydrogen pop instead of burn. As you can tell, I'm thoroughly enjoying myself. Popping bubbles with fire. All right. I know, right? All right, so that's everything that I have for y'all with the male science experiment. I'm gonna go ahead and let it bubble on out, and it'll make my cleanup easier and safer. But So, a home experiment that you can try is get some iron oxide powder. Now, you can actually get different colors. So, I looked up uh, iron oxide powder online, and I just switched my browser to shopping, or not browser, but switch the Google search to shopping, and it'll tell you where you can order this stuff, or if there's a local, like, because I saw like Amazon carries it, but I don't know if it's their distribution or if it's actual like Amazon, place. Because some places actually do have Amazon stores. I don't have one here, so I'm assuming they mean like you can order it from Amazon. But you can order it, and it's not expensive. It's uh, like $15 or $10 or something for like several different pounds of it. And then they have some where you can get multiple colors like yellow, red, blue, black, white, and you can do this in multiple. You can either get like test tubes, but you want it to be something glass and something that you don't eat out of. So don't do experiments and things that you eat out of. Like that jar, I'm gonna throw that jar away after this. As you can see, I can just buy more jam and get another jar. But what you do is you take some iron oxide. It doesn't have to be a whole lot. I would say probably about like 2 or 3 tablespoons, maybe, and mix it in with some olive oil. And then you want it to be kind of like a paste. So you don't want it very really oily. You want more iron oxide than oil. Really just want the oil to make the paste. You want it to, all the iron oxide to be mixed with the oil. You get like a small, like a styrofoam or a paper bowl or something like that, and you can mix the different colors, that you want in separate bowls. And then you would take a test tube filled with water, and you would drop your oil iron oxide mixture into these different test tubes. And like I said, get different colors. And it could be a very pretty experience, because I'm thinking about it in my head. I'm like, that would be really pretty and very cool. And then you get small magnets, and you take the magnet and pull it up the side of the test tube or whatever glass container that you have that you're doing this in. And the iron is magnetic, and it'll pull a blob of the iron oxide out of the little paste, because the oil makes the iron oxide blob hydrophobic. So that's why you want the water, because then it creates a substrate for the iron to move through, and it makes really cool. It almost has like kind of a lava lamp kind of look to it. And then you can also try using 2 or 3 different magnets at different places in the test tube to see how the blob moves around in that solution. And you can even put different colored blobs in the same test tube, and then that's when you get your little rainbow mix of colors there. So if you try that, please, please, please take pictures, take video, and share it to the group. Post it, and tag us, and we will definitely love to see that. If I get my hands on some iron oxide before the end of this week or month, I'll do a video, and I'll show y'all that as well. But that definitely sounds like a fun experiment. It's a non-toxic thing. Iron oxide is not toxic. Don't eat it though. Don't eat it though. But it's not toxic to your skin. But still wear gloves, safety first. Get you some goggles or some type of eye protection. We're all about safety over here. I don't do the. I think her name was Sally. Don't quote me on this, but I'm like old school. They have like the safety posters in the labs, and Sally went blind by not wearing goggles and handling. I think it was like an acid solution she dropped and like splashed in her face, and now she's blind with her seeing eye dog and a cane. And I'm like, I don't want to be Sally. So I have always worn my goggles, especially when handling very dangerous stuff. Like if it's not water, if it's something that's completely non-toxic, and I'm not like mixing, other stuff in it, I'm wearing goggles. And technically, like you should be doing, safety procedures when you're cooking and all of that too. So yeah, that's my safety soapbox. All right. So this was fun. I love fire. And I'm pretty sure there will be more experiments in the future, including fire. But in what are we at? So in about an hour, we have Rock True Beats. I love saying that. Next, like up next, Rock True Beats. So I'm excited. I'm gonna be co-hosting that. So once we finish up here, we'll be heading over there. And if y'all want to tune in for that, I don't know how, but somehow we always end up talking about some science in that. So and I believe we have. Do we have a guest tonight? Is there a guest? And for next week, we'll be getting into. Uh, Let me double check because I have the schedule, and I just want to make sure I'm telling y'all correct, and not sending y'all off somewhere like, yeah, we're doing this, and we're definitely not doing that. So let me check my notes so I can tell y'all exactly what we'll be talking about next. Oh, okay. So we're going to be talking about our group 3 elements. So that's boron, aluminum, gallium, indium, tellurium. I forget what NH is, but that's usually one that people don't ever encounter. I don't even think scientists use that. Like they literally just discovered it as an element just to discover it, but I don't think it's really used in anything. But I'm going to research that and I'll tell y'all for certain next week. So we're doing our group 3 elements, and we're going to be going over the nifty chemistry of boron. Like boron is kind of interesting, and so is aluminum. Aluminum is super interesting, and it actually puts me a lot in the mind of magnesium and kind of how it's like. Oh, so look, so here, our magnesium has completely dissolved, so there are no more magnesium strips in the solution. So because we don't know because we don't know how much sulfuric acid is left in there, I'm going to fill this up with some water. I'm going to pour out my little soap thing over here. I'm going to fill this up with water, pour some in this jar, and then I'm going to pour the acid solution into the water. That's how you dispose of acid. You want to pour acid into water because that's going to, as you know, that's right. Yeah. Because if you pour water into acid, the acid can react with the water. So you want a very, very dilute situation. So if you're pouring acid into water, it's going to dilute the acid as you're pouring it into the water, and you won't get a reaction. So I did that backwards one time in chemistry class, and I started a fire. And I think I had spilled some sulfuric acid too. That's how I started the fire. I spilled sulfuric acid because I wasn't doing it right, and it made an exothermic reaction, and I got startled and I knocked over the sulfuric acid. And so I hurried up and grabbed a paper towel, threw it on the sulfuric acid, and it burst into flames. So we learned from our mistakes. Luckily, I didn't burn the lab down. Nobody was hurt, but I definitely learned you don't wipe up acid with paper, and you absolutely want to have a dilute situation when dealing with acid. So you want to keep lots of water handy and have a beaker of water that you pour your acid into. So that is all I have for y'all. I'm excited to talk about our group 3 elements next week. And what they say, two's company, three's a crowd, but not with boron, and and you're gonna find out why. So I'm super excited, and yeah, my nerd is showing, isn't it? Yeah, my nerd is turned way up. Oh. And I'll see y'all over on RockTrue Beats, and that's in an hour, right? Because it's 7:00 here. I'm Central Time. I'm Eastern time. And it starts at 7 Central Time. So yes, it's in 1 hour. So that being said, this was a quick one because I didn't have, like I said, I didn't have the stuff for the home experiment, because usually we end up with 3. I do the 2 that Mel Science sends, and then I do one home one, and and I gotta get my baby. I think she's been upset this entire time. So I gotta go get my daughter together and calm her down. And yes, and Rock True Beats will be live in 1 hour. So tune in and get fed, and groove with us, and learn with us, and love with us, and of course, rock truth with us, or nothing at all.